telescopes like Hubble, it was a fuzzy big ball. And the old astronomers with the little telescopes just called it a star, you know, like a strange looking star. But it's the biggest clump of stars, 10 million of them, in any place in the Milky Way galaxy. Okay? So if we think about this telescope being able to take us on this long journey, and we're going to travel from the front of the room to the back, so what do you think we're going to travel across?
Travel across the galaxy.
So we're going to travel across our galaxy, the Milky Way galaxy, and we're going to travel to other galaxies, and so we're going to travel across the what?
The universe.
The universe. So we're going to travel all the way across the universe. Now, Hubble is going to take us on that journey, and it's going to see light from pretty far away. So let's kind of take a peek and see how far we go. So if we start with our solar system, you know some of the planets in our solar system, right? So the stars up front are burning out really bright ultraviolet light. And you know you wear sunglasses when you are in the sun, right? So the ultraviolet light doesn't hurt your eyes, right? Okay. So we've made a little camera setup like the Hubble Space Telescope so we can see in ultraviolet, visible light, or infrared light. And so if I put my hand in here, you can see in the upper corner what my hand looks like in ultraviolet, in visible light, and in infrared, right? And if I take my hand away, you see the evidence of the warmth of my hand in the infrared.
Can I put my hand in it?
In just a moment. Put your hand in the bag. Put your hand in the bag. Put the bag in the box, and tell us. See, so the cloud that's blocking the star from being seen in visible light can see your hand in infrared. So we can see through the dust to see the young star in infrared light. In ultraviolet, we can't see through the dust. In visible light, we can't see through the dust, right? But in infrared, we can see more of this really old galaxy that's stretched across the sky. And so it allows us to learn more about what's going on in our universe than just what we can see with our eyes. Okay?
How about if we can see everything? Like small things, big things?
So we use all of the spectrum. So Hubble sees in ultraviolet, visible, and infrared. But we also have telescopes that can see in X-ray, so we can see our star in X-ray light, and we can see other stars in X-ray. And then we also listen in radio waves. So we can see stars that are really old, or their energy is at a different wavelength. So we look all across, but Hubble looks in this area of the optical wavelengths. In the universe, there's water everywhere. And so what the scientists have learned over many hundreds of years is on this planet, everywhere we find liquid water, we find life. You know?
Like animal life?
Yes.
Plant life?
Yes.
Snow life?
Well, snow isn't life. Snow is ice. So we have ice and water and but the moon orbits around the Earth, right? So what creates the shadow? Is it a shadow, or is it the only light that we see of the moon?
It's a shadow?
So what happens is the moon moves around the Earth, right? Moves around the Earth. The sun and the Earth in 1 month stay in roughly the same position, right? They're, roughly, I mean, we move 1/12 of the way around in 1 month. But the moon makes this full circle, right, around the Earth. So when the moon is right here, how much of the sunshine that hits the moon can we see from the Earth?
A little.
Very little, right? I can just barely see the front of my thumb when the moon is right here, right? Now, when the moon comes right here, how much of the moon can I see that's lit by the sun? About half of it. And then when the moon is right here, how much of it can I see that's lit by the sun? The full moon. So the full moon is opposition to the Earth, right? And then the new moon is just barely off the line of the analogy. It's that Jupiter has this moon, Europa, and it has lots of water under the surface of Europa. And Hubble has been able to see the surface of Europa spewing out this water. And so we ask this question again. So now on Earth, wherever there's liquid water, we see what? Life. So now we have this moon near Jupiter, and we know there's liquid water because it's spewing up out of the surface. So what do you think we want to do? We want to go there and drill a hole and taste the water. That's what we want to do. We have no idea. We have no earthly idea. But we want to go there and taste the water.